All right, today we're going to dive into some invisible chemistry, the kind that's happening all around us every single day. You know that awful feeling of indigestion after a big meal? Or that crazy moment a curry stain changes color on your shirt? Well, believe it or not, the secret behind both is the exact same science. Let's get into it. Okay, let's paint a picture. You've just finished a huge, delicious meal, and then it hits you. That burning feeling, right? We all call it acidity. So you run to the kitchen. What do you grab? Some lemon juice, a splash of vinegar, or maybe you mix up some baking soda and water. What's the right move here? And how about this one? It's a classic laundry nightmare. You get a turmeric stain from some curry on your favorite shirt. It's super yellow. But then the weirdest thing happens. The second you hit it with soap, poof, it turns this deep reddish brown color. What in the world is happening there? Well, the answer to both the indigestion and the color-changing stain, it's all about the hidden world of acids and bases. Seriously, they're the secret agents of the chemical world, reacting all around us. And once you know their secrets, I promise, you are going to start seeing this stuff everywhere. So let's start with the basics. What even are they? Well, the simplest way to tell them apart is by taste. But, and this is a huge but, please do not go around tasting random chemicals. We're only talking about things you already know are safe to eat. Okay, so think about it. Acids are what give things that sour, tart kick, right? Like a lemon. Bases, on the other hand, they're bitter. If you've ever accidentally gotten a bit of baking soda in your mouth, you know that taste. It's not pleasant. This difference, sour versus bitter, is our first big clue that we're dealing with two very different types of chemicals. Okay, so since we can't taste everything, how do we tell them apart safely? This is where it gets cool. We use these things called indicators. Think of them like chemical spies. They go in and they change color to signal whether they found an acid or a base. It's pretty neat. And you might be thinking, these are some high-tech lab chemicals, right? Well, some are. But the coolest indicators, they're not in the lab at all. They're actually all around us, just hiding in plain sight in nature. Get this. Litmus, maybe the most famous one, comes from lichen, and the color in turmeric, red cabbage, even flower petals from hydrangeas, they all work as natural indicators. It's wild. Of course, for super precise work in a lab, scientists have cooked up their own synthetic ones, like phenolphthalein. And aha! This is it. This solves our curry mystery. Turmeric is a natural indicator. So when you put soap on it, which, spoiler alert, is a base, the turmeric reacts and changes color. So you're not just cleaning a stain, you're literally running a chemistry experiment on your shirt. Okay, so now we know how to spot them. Let's move on to the really fun part, how they react. What happens when an acid or a base actually bumps into something else? This is where the action is. So, check this out. It's a classic chemistry demo. You take a piece of metal, say zinc, and drop it into an acid, and right away, it starts fizzing like crazy. But here's the thing, it's not just dissolving. A full-on chemical reaction is happening, and it's producing a totally new thing, hydrogen gas. So how do you know it's hydrogen? Well, there's this really cool and simple test. You just bring a lit match or a splint near the top of the test tube and pop! You get this awesome little popping sound. That's the hydrogen gas igniting. Super simple, super effective. Okay, but the main event, the most important reaction of all, is what happens when an acid and a base meet each other. It's like a chemical showdown. They don't just hang out, they totally cancel each other out. It's called neutralization. And the end result is always a salt and plain old water. And boom, that brings us all the way back to our first question about indigestion. That awful burn, it's from too much hydrochloric acid in your stomach. So what do? You introduce a base. Something like baking soda and water neutralizes that extra acid. It's a real-life neutralization reaction happening inside you. So yeah, baking soda was the answer. Okay, so we're getting the hang of this. Acids are sour, they react with metals, but what makes something an acid? Like down at the tiny, tiny molecular level. Well, the secret is all about what happens when you mix them with water. So here's the key. When an acid hits water, it breaks apart and releases these tiny, positively charged things called hydrogen ions. We just call them H+ ions. And these little guys are the source of all of an acid's power. They're the reason it's sour, the reason it reacts, and because they have an electrical charge, they can carry a current. That's why in this experiment, the light bulb is on. Now, this is important. When we talk about a strong acid, we don't just mean it's more dangerous. What it really means is how good it is at releasing those hydrogen ions. A strong acid, like the kind in your stomach, releases a ton of them. A weak acid, like the one in vinegar, is a bit more stingy. It only lets go of a few. So if the number of these hydrogen ions is so important, how do we measure it? Well, scientists came up with a really elegant solution, a simple scale. And this scale is now, it's absolutely crucial for everything from farming to making sure our water is safe to drink. It's called the pH scale. And fun fact, the P actually stands for the German word Potenz, which means power. So pH is literally the power of hydrogen. It's a brilliant system that just gives us a number from 0 to 14 to tell us exactly how acidic or basic something is. And here's what that looks like. Down at the bottom, at pH 0, you've got super strong acids like battery acid. Way up at the other end, at pH 14, you have really strong bases, or alkalis, like drain cleaner. And right there in the sweet spot, at pH 7, that's perfect neutrality. That's pure water. So, the takeaway is super simple. Anything below 7 is acidic. Anything above 7 is basic. And 7 is neutral. And the further away you get from 7 in either direction, the stronger it is. Now, why does this matter so much? Because the scale is logarithmic. Whoa, big word. But all it means is that each step is a 10-fold jump. So something with a pH of 4 isn't just a little more acidic than something with a pH of 5. It's 10 times more acidic. And that's why our bodies have to work so hard to keep our blood in a super narrow pH range just to stay alive. It's why a small shift in rain pH can cause acid rain and wipe out a lake. This balance is, well, it's everything. And if you want to talk about extreme, check this out. Our planetary neighbor, Venus, its clouds aren't water like ours. Nope. They are made of thick, swirling, super corrosive sulfuric acid. Can you even imagine that? So that leaves us with a pretty big question, doesn't it? Now that you know what you know about acids, do you think life as we know it could possibly exist there? It just goes to show you, understanding this simple chemistry isn't just about fixing indigestion. It helps us understand the fundamental rules for life, not just here on Earth, but maybe anywhere else in the universe.